children, welcome back to Chem is Try channel. My name is Mahantesh Shettar, and in the previous class we are discussing about the question paper. I discussed about section 1 2020 question paper. So in this session we are going to learn about section 2. We're going to solve section 2. So section 2 we have to attempt any 4 questions out of 6 questions. Okay, so best way is first you have to identify the questions which are easy to you. Then if you feel all the questions are difficult, then you have to find the question where you know the maximum number of answers. Okay, so then if you have the time, you can also attempt more than 4 questions. So whichever questions get more marks, that will be taken whenever the evaluation happens. Okay, let's start the session. The following table represent the elements and the atomic number. With reference to this, answer the following using only the alphabets given in the table. Okay, element PQR, atomic number 13, 7, 10. Questions are given here. This is a very simple question. First of all, whenever such questions come, you have to write straight away its electronic configuration. Okay, so 13, 2, 8, 3, 7, 2, 5, 10, 2, 8. So what electronic configuration tells us? Okay, very important. Electronic configuration tells us total number of shells given by or give the number of periods. Okay, so you can see here 13. There will be 3 shells means 3 periods. 2 shells, 2 periods. 2 shells, 2 periods. And the valence electrons will give us the group number. So here 3 means group 13 or 3a. Okay, this is old notation, this is new notation. 5 means 5a or 15. 8 means obviously complete octet, means noble gas. Okay, now come here. Which element combines with hydrogen to form a basic gas? Obviously, a basic gas is the only one gas which you know is ammonia. So ammonia is NH3. Nitrogen atomic number is 7. So therefore it should be Q. Which element has an electron affinity 0? Very important question. Point to be noted, electron affinity value will be in negative because it is the energy released when an electron is added to the outermost shell of neutral gaseous isolated atom. So therefore the electron affinity should be negative. But if it is 0 or positive, okay, 0, that will be for noble gases. So here noble gas is the one which has complete octet, that is R. So obviously 3 should be whatever left, P. Name the element which forms an ionic compound with chlorine. So P. Okay, very simple question. Let's go to the next question. Yeah, mark this question. This is, you can say, in all the question paper, this is a compulsory question. Definitely this question will be there, okay, for 3 marks. That is electron dot diagram. So there are a lot of compounds, some 3 organic compounds and some 6 to 8 covalent compounds. If you practice them, you can get easily 3 marks. Take it. Here, let me give you, they have also given you atomic numbers. So first one, calcium oxide. Calcium oxide formula is CaO. Read the instruction here. Represent the electrons by dot and cross. When there are 2 elements, so one of the elements outermost electrons will represent by dot, and another element's electron you will represent by cross. Okay, electron dot diagram is nothing but you're just showing the valence electron. So for calcium, atomic number is 20, so write the electron configuration 2882. So to just show the two electrons, so I will just use here dot. Okay, and what is their oxygen? Oxygen atomic number 8, so it is 2,6 to become stable. Okay, and now how to represent the electron dot diagram for this? 6 electrons you have to show here, 2 here. Yeah, since this is a different atom, you show it by cross like this. Okay, now what happens? This is a ionic compound. So in ionic compound, electrons are donated by the metal to the non-metal. So both electrons are donated to the oxygen. So you have to show this. Just put here plus, show the arrow mark. So what happens here? When calcium gives both its electron, it will have the +2 charge. Oxygen gains the 2 electrons. So put it in bracket. It already has 6 electrons. Put those, all the 6 crosses, and 2 electrons by the calcium. So show the dots. So because it is gaining 2 electrons, it will have -2. But usually we don't show it like this. We just write it CaO. Okay, this is the electron dot diagram for calcium oxide. Similarly, we can write it for chlorine as well as water molecule. If you take chlorine molecule, it contains 2 chlorine atoms forming a bond, single covalent bond. Since both have the same, both are the same atoms, you need not to show dot and cross because both are same atoms. So just show with dot. Chlorine atomic number 17 means 287. 287. So show 7 electrons around the chlorine atom. This is electron dot diagram for chlorine atom. So since this is a covalent molecule, the electrons will be shared between the two. So its molecular structure will be like this. Keep in mind here no ion is formed because this is a sharing of electrons, covalent bond. Similarly, water molecule we can write here, third one, water molecule. Since water molecule is made up of O, H and H. So now we'll show O with one dot and H with cross. This is also covalent. So we'll write O here, 2,6. So 6 electrons. So this time I'll just show it in a different way. Here one dot, here one dot. Now H, hydrogen only one, so I'll just put cross here. Another hydrogen I will put here, cross. So now what happens here? The electrons will be shared. So you have H cross dot oxygen. Its 6 dots should be there. One more cross by hydrogen. So this is the electron dot structure for hydrogen atom. Okay, let's go to the next question. C. Choose the correct word which refers to the process of electrolysis from A to E to match the description 1 to 4. So you just have to write whether it is A, B, C, D, E, or even if you want you can write A oxidation, B cathode, like that as well. Okay. Conducts electricity in aqueous or in molten state. So obviously it should be an electrolyte, D, because that is the one which conducts electricity in aqueous or molten state. Loss of electron takes place at anode. Now I want to give you one interesting mnemonic here. Remember this, if you know, I think the chemist, Indian chemist CNR Rao. Similarly, you can remember this CNR Pao. What is this? C, cathode, N, negative, R, reduction. Okay. Similarly, Pao, P, positive, A, anode, O, oxidation. Okay, so then you will not have confusion what is happening at cathode, which is negative and which is positive. Okay, and also for many people have which is reduction, which is oxidation. You can remember one more mnemonic for that: oil rig. Okay, oil oxidation is loss, rig reduction is gain, loss of electrons, gain of electrons. Okay, now loss of electrons, electron takes place at anode, so what you will call this as? Loss of electron is oxidation. So where is oxidation? A reducing electrode, now you can check here, C and R, so it is cathode, cathode is B. Then electrode connected to the positive end or terminal of the battery, so that will be anode. So anode is connected to the positive, PAO, POW. So anode is C. Okay, so this is question number 2. Okay, let's go to next question, question number 3. So A, Bayer's process is used to concentrate bauxite ore to alumina. Give balanced chemical equations for the reaction taking place for its conversion from bauxite to alumina. So you can see here 3 marks. If you remember, Bayer's process includes 3 equations, therefore it is for 3 marks. Okay, you need to write all the 3 equations, that too balanced chemical equation. First of all, balancing you know. Okay, so if you are able to find the skeletal equation, I think you can balance it. For this I will give you one simple technique, because it is a little difficult to remember all the equations for sure. Okay, so what we have to do here, we have to make a flow chart for that. So what is the flow chart for that is, bauxite, when we take bauxite ore, its molecular formula you already know, Al2O3.2H2O. So to this bauxite ore we add sodium hydroxide solution. Okay, so when you add sodium hydroxide, if you remember, aluminum oxide is amphoteric, it reacts with the base as well, and it forms sodium aluminate, NaAlO2. So this is sodium aluminate. So this sodium aluminate is soluble in water. So what they do, there are some impurities. If you filter off impurities, okay, for that purpose it is done. So here these impurities are called red mud. Okay, so the impurities are removed here. Then to this, what they do, they will simply add excess amount of water. It is also called as hydrolysis. So sodium aluminate will hydrolyze and form aluminium hydroxide, which is a precipitate. Precipitate is insoluble solid. Now you have a precipitate. This one, when you filter, you will get a solid aluminium hydroxide. All the other impurities are removed. What other filtrate will be there? It will be your again sodium hydroxide solution. Sodium hydroxide solution formed. So that will again reused here in the first step. Next, if you just take the solid aluminum hydroxide and heat it, you will get alumina, Al2O3 and water. So this is your final thing. So now this is a summary. So now you know which are the reagents, which are the starting material, which are the products. So now we can write all the 3 equations. Equation number 1. So bauxite ore you take Al2O3.2H2O. You add sodium hydroxide solution. Okay. Then you will get sodium aluminate, NaAlO2, which is again soluble, plus water and other impurities which are removed. Next, sodium aluminate you will take, NaAlO2, You can see these are the now reactants. Add excess of water. This is called as hydrolysis. So you will get aluminium hydroxide, which is a precipitate, plus sodium hydroxide formed back. You can see sodium hydroxide is the starting material here. So then you want only aluminium hydroxide, and you just heat it, hydroxides, it will convert into oxide and water is removed. Okay, these are skeletal equations. If you balance this, you will get 2 NaOH here, 2 NaAlO2, 3H2O. Here again NaAlO2, 3H2O, AlOH thrice plus NaOH. Here aluminium hydroxide 2 and 3 water. So these are the three equations which are used. Next, the question number B. Complete the following by selecting the correct option. So this is a simple question. pH of acetic acid is greater than dilute sulfuric acid. So acetic acid contains dash concentration of H plus ions. Okay, pH is greater. Okay, for acids the pH should be smaller to be the stronger acid. But here the pH of acetic acid is greater means acetic acid is weaker. So therefore weaker acid means low concentration of H plus ions. The indicator which does not change color on passage of HCl gas is HCl is acidic gas. Methyl orange changes its color. Moist blue litmus changes its color. Phenolphthalein remains colorless. So it should be phenolphthalein. The acid which cannot act as an oxidizing agent is concentrated HCl. Both concentrated sulfuric acid, concentrated nitric acid can act as oxidizing agents. Okay. Question number C. Match the gases given in column 1 to the identification of the gases. This is a very nice question. Okay. Here they are testing your practical knowledge. Hydrogen sulfide, nitric oxide, carbon dioxide, sulfur dioxide. So you know some of them. Carbon dioxide, sulfur dioxide turns lime water milky. Okay, but turns acidified potassium bicarbonate solution green cannot be shown by carbon dioxide. It should be by sulfur dioxide. So for question number 3 it will be B. For 4 it will be A. Then what is left? Hydrogen sulfide and nitric oxide. Nitric oxide is NO. You can see options. Turns reddish brown when it reacts with oxygen. Yes, NO plus O2 if you do, you will get what? NO2. So NO2 is a reddish brown gas. Therefore, nitric acid is C. And therefore, hydrogen sulfide will be D. Turns moist lead acetate paper silvery black. So here lead sulfide silvery black is lead sulfide solid is formed. Okay, so this is question number 3. Okay, next question number 4. Differentiate between the following pairs based on the information given in the brackets. So differentiation always should be based on what they have given information. Okay, conductor and electrolyte. So always while writing the differences, you have to make 2 columns. So for example here conductor and electrolyte. So you have to make like this 2 columns. Make it neatly. Conducting particles. So in conductors and electrolytes, conductor, the conducting particles are free electrons. So electrons which can move. But in electrolyte, the conducting particles are free ions. Therefore, either in aqueous state or in molten state, only they will conduct electricity. In solid state, the ions are not free. Okay, cations and anions. So if you come to cations and anions, formation from an atom means when the cation is formed, when the anion is formed. So cations are formed by loss of one or more electron from an atom, usually metals. Anions are formed by gain of one or more electron by an atom. Okay, very simple question. Acid and alkali, formation of type of ions. So acid we know, and alkali is the soluble base. Acid forms hydronium ion, that is H3O plus in water as only cation. There should be no other cation. Whereas alkali forms hydroxyl ion, that is OH minus in water as only anion. Okay, so these are the differences. Differences will be very easy questions. If you go to question number B, in that, draw the structure of isomers of pentane. Very important question. Pentane, you can see it ending with ane, so it should be an alkane. So general formula for alkane is CnH2n plus 2. So pent means carbon number 5, so C5H 2 into 5, 10 plus 2, C5H12. So isomers are, what are isomers? Isomers are those which have same molecular formula but different structural formula. Okay, so therefore it is for 3 marks, means you have to guess that there will be 3 structures. Okay, so one straight chain you can write 1 2 3 4 5 carbons, and every carbon should be having 4 bonds. So structural formula always show all the bonds, otherwise you may lose marks. Okay, some people write the condensed formula, which is not good. So this is what straight chain. Common name for this is N-pentane. IUPAC name will be simply pentane. Next, just try to make a branch here. So this is actually chain isomerism. 1 2 3 4. I will make one carbon here. So now satisfy all the bonds with hydrogen everywhere. Okay, here hydrogen. Don't forget, every carbon should have 4 bonds. So this is common name for this is isopentane. If you don't remember common name, it is important to remember common name for pentane. Okay, the IUPAC name will be 2-methyl butane, because the main chain is 1 2 3 4 but, all the single bonds N. Second position you have methyl group. One more you can write is 1 2 3 4 5. So this time I will not show hydrogen, you have to show in the exam. So H3 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 H3. This is called as neopentane. So you can try naming IUPAC name. 1 2 3 is the propane. So at second position you have 2 methyl groups, so 2 dimethyl propane. Okay, so these are the 3 isomers: N-pentane, isopentane and neopentane of pentane. Next question. Hydrogen chloride gas is prepared in the laboratory using concentrated sulfuric acid and sodium chloride. Answer the questions that follow based on this reaction. Okay, give the balanced chemical equation for the reaction with suitable condition or conditions if any. So 4 marks, 4 questions, so every question carries 1 mark. Okay, so I'll just write here, just remove this. If you want the answers, you can go back and check. So here for C, first question, balanced chemical equation for reaction for the preparation. So they have already given the reactant sodium chloride NaCl, sulfuric acid concentrated one H2SO4. You should write concentrated. If you don't write concentrated, you will not get marks. Condition below 200 degrees Celsius. Below 200 degrees Celsius. So what happens here? An acid salt is formed, that is NaHSO4, sodium bisulfate, plus HCl gas. HCl gas is produced. So if we check this, it is already balanced. Condition is only less than 200 degrees Celsius. Next, why is concentrated sulfuric acid used instead of concentrated nitric acid? Okay, this is very important question. As I already told you, concentrated sulfuric acid can have three natures. Okay, non-volatile acid, okay, then dehydrating agent, then dehydrating agent, then yes, oxidizing agent. So here, because of its non-volatile nature, because of its point, I'm just writing you the keywords. Because of its non-volatile nature, it is used even in the preparation of nitric acid also. It is used for the same reason, concentrated sulfuric acid instead of concentrated nitric acid, because concentrated nitric acid is volatile acid. So if we use volatile acid, that will volatilize during the reaction and it will mix with HCl vapors as well. So you will not get the pure HCl gas. So that's the reason. The key term here, non-volatile nature of concentrated sulfuric acid. How is the gas collected? So remember, you will not have confusion that HCl gas is heavier than air. So we are collecting HCl gas over air. So since it is heavier than air, we use upward displacement of air. Okay, this is the method. For ammonia gas will be lighter than air. So there you will use a downward displacement of air. Name the drying agent not used for drying the gas. Since this is acidic gas, you use the concentrated sulfuric acid, but not used means basic drying agents you do not use. Basic drying agents are quicklime. So you can write here quicklime or phosphorus pentoxide, phosphorus pentoxide. Many students do the mistake, instead of writing the name, they'll just write the formula. So if you write the formula, you'll not get the marks. Okay, be very alert. So name means you have to write the name. Okay, so yeah, so this is the section 2. I will call this as part 1 of the section 2. The remaining questions I will cover in part 2. Okay, so until then, prepare well for the exams, read well, take care, bye bye.